Number 9. Okay, this one is a doozy. This one I've assigned in the past and it trips students up. So let's look at it. Okay. So you'll notice that these exponents, these rational exponents, are written a little bit differently, but that's 1/2 and that's 5/2. So what I'm going to do first, I'm going to factor, and I'll tell you what I'm going to factor. I'm going to factor a sine to the 1/2 theta, cosine theta. You'll notice they both have those. There's that, there's that, there's that, there's that. So I'm going to factor out a sine to the 1/2 theta, cosine theta. Write a bracket here. So that'll be multiplied by 1. Sine half theta times cosine theta times 1 is this term. Minus, when you multiply, you add exponents. So that'll be sine to the 4/2 of theta, because half and 4/2 is 5/2. And that's it. That equals cosine cubed of theta, square root of sine of theta. Alright, now, sine 4/2 I'm going to simplify, which basically I'm reducing that exponent. So I'm going to have 1 minus sine 4/2 is 2. So I have the sine 1/2 theta, cosine theta out here, equals cosine cubed of theta, square root of sine of theta. Now 1 minus sine squared is Pythagorean identity. And when you do these problems, that's what you have to recognize most. So that 1 minus sine squared is cosine squared theta. I'll keep the bracket just showing where it's coming from. Then I still have the sine of the 1/2 theta, cosine theta, equals cosine cubed theta, square root of sine theta. Students always ask me if you have to rewrite this every time. You really don't, but I think it helps you keep track of what you're going for. So now I'm going to multiply. And remember, when you multiply, you have to remember that you're adding exponents. So that'll be cosine times cosine squared is cosine cubed of theta. And sine of the 1/2 is really just square root of sine of theta, equals cosine cubed of theta, square root of sine theta. And oh wow, do you see? We have the same thing. We're done. Sometimes you just have to keep plugging along and you realize that you've got it. Alright, there's one more example. This is the last one. Let's see what it is. Alright, this is phi. It often looks like that when you see it written out. Written like that, phi. Okay, so I have two terms that are being added. I have one term because they're multiplied now, so I'm going to see what we got here. Here's a quotient identity. A good trick when you're kind of not sure what to do is to turn the sines and cosines. So that's sine of phi over cosine phi plus cosine phi over sine phi equals secant of phi cosecant of phi. Okay, now I have two fractions, and if I add them up, I'll get one fraction. So let's get a least common denominator, right? So on this side, I'm going to multiply by sine over sine, sine of phi over sine of phi. And on this side, I'm going to multiply by cosine phi over cosine phi. So when I multiply, I get sine times sine is sine squared phi over sine phi cosine of phi plus cosine squared of phi over sine of phi cosine of phi equals secant of phi cosecant of phi. Yeah, and again, that just rewriting the right side keeps it as an equation, its identity, and then it keeps an eye on your target, right? So I'm going to add these two fractions up, and I'm going to get sine squared of phi plus cosine squared of phi over sine of phi cosine of phi equals secant of phi cosecant of phi. Okay, now, oh, that's Pythagorean identity. Hot dog. Alright, sine plus cosine, sine squared plus cosine squared is 1. Equals secant of phi cosecant of phi. Now, when you realize this, 1 times 1 right? So I have 1 over sine of phi times 1 over cosine of phi. So I separate the fractions, right? And I bet you can see where we're going. So 1 over sine is cosecant of phi. 1 over cosine is secant of phi. And there, we did it. QED. And I separate the fractions, and then I'm gonna, oh yeah, what step did I do here? I did reciprocal identities. Okay, so you just have to know the identities and know how to apply them. Good luck.